Hello everyone. Plan for this recording is to talk through graphing radicals. We'll look at square roots and cube roots. Look at them shifted left, right, up, down, and that's about it. So first thing, when we graph something that we don't know what it looks like, our first step is to graph what's called the parent function. The function before it has been shifted left, right, stretched vertically, horizontally, etc. So my parent function for a square root function is just y equals the square root of x. So as we look at that parent function, again, I don't know what it looks like. So my first step is to plot some points. Let's plot some points. Let's get a feel for what this graph looks like, and then we'll talk about how to shift it and translate it and transform it. So we need to plug in values for x. So let's plug in some careful values, some values that we think about before we just plug them in. First question, can I plug in a negative? The square root of a negative is going to generate something called I, which we don't want. We can't plot that on an xy axis, on a real xy axis. So I need to pick values that are positive. So positive or 0. Can we plug in 0 for x? Sure. What number times itself will give me 0? That's what the square root of x is asking. And the answer is 0, because 0 times 0 is 0. All right, let's pick another number. Let's pick it carefully. Pick a number whose square root will be a whole number. I don't have to pick those numbers. I can pick anything I want. That's a positive number. But we might as well pick some nice, neat numbers that will allow us to get a feel for this graph fairly easily. 1. What number times itself gives me 1? 1. 1 times 1 is 1. I'm going to jump up to 4. What number times itself gives me 4? 2. Jump up to 9. What number times itself gives me 9? 3. And I can go to 16, but you notice on the right-hand side there I have an xy axis that goes from a negative 10 to 10. And my next point would be 16, and the square root of 16 is 4, but that's off my graph, so I'll stop at 9. Let's plot those points. When x is 0, y is 0. Missed. When x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. Do we see the shape? Sketch a quick graph. Connecting the points, and there is the shape of a square root graph. All right. Let's look at what if I did this to my graph, or my equation. What if I put a plus 2 out there? If I put a plus 2 out there, what it does is it adds 2 to every one of these y values, right? I square root 0 first, I do that first, and then I add 2. So my next point, or the point of the new equation, would be 2. When x is 1, the square root of 1 is 1, plus 2 is 3. The square root of 4 plus 2 is 4. Let me show that one real quick so we can kind of get a feel for it. I plugged in 4 for x. The square root of 4 is 2, plus 2 gives me 4. So basically what is happening is I'm adding 2 to every y value. I'm adding 2 to the answer of my square root, which is the y value. So what does that do to my graph? So if I graph what's in black, when x is 0, y is 2. When x is 1, y is 3. When x is 4, y is 4. When x is 9, y is 5. I get the same graph, but shifted up 2. What would it look like if I went minus 3? Leaving these here just so I can see it, I'll call that y2. I'll call this y3. Let's leave those points there just so I can see what it does. So if I took the square root of 0, right, putting in 0 for x, and then I subtracted 3, I would get a negative 3. we should quickly see that I am simply going to subtract 3 from every y value. Graphing that in red, I get 0, negative 3. I get 1, negative 2. I get 4, negative 1. I get 9, 0. I get 16, 1, but that's not on my graph. Kind of missed that one. I get that there. So what can we say about a number out here? It does what it says, and it does it to the y-coordinate. If it says plus 2, it really does move it up 2. If it says minus 3, it moves my graph down 3. So numbers that are outside of the square root will affect the y, and it will do opposite. Sorry, not opposite. It will do the same as what it says. Numbers that are outside of the square root will affect the y values. It'll make it go up or down, and it'll do exactly what it says. If it says plus, it goes up. If it says minus, it'll go down. Okay. What about if I extend this and put a minus 2 inside? Go back to our parent function. Let's compare these now. So what happens if I put in a 0? If I put in a 0 for x, I get the square root of a negative 2. Well, we said you can't square root a negative because the square root of a negative 2 isn't possible. So that doesn't work. What about a 1? If I put in a 1, I get the square root of 1 minus 2, which is the square root of a negative 1. That doesn't work either. So what number do I need to plug in order to make this 0 or greater? 2. Because 2 minus 2 is equal to 0, and the square root of 0 is 0. So now I'm going to change my x column, not my y. I'll call that x2. I can't plug in 0. Let me go to 2. Well, let's just start here. Let's plug in 2 where the 0 is at, because that's my starting point, right? When x is 2, I get the same y value as I did when I had an x being a 0. So now let's just think about this carefully. This expression underneath here needs to be my 0, 1, 4, 9, etc. So really, every x value needs to be 2 more than what I have listed here. So 3, 6, 11, and so on. Why? Because my first step is to subtract 2 from whatever I plug in for x, and then take the square root. So if I plug in now 3 for x, the square root of 3 minus 2 is equal to the square root of 1, which is equal to 1. Plug in 6. The square root of 6 minus 2 equals the square root of 4, which is equal to 2. So in order to get the same answer as I had when I had the original y equals square root of x, my x values have to be 2 units bigger, not 2 units smaller. This looks like it says subtract 2 from every x. It doesn't say that at all. It says, well, it does, but it doesn't say that in my graphic formation or in my graphing it on the graph. Because what happens is when x is a positive 2, I get the same answer. So when x is 2, y is 0. When x is 3, y is 1. When x is 6, y is 2. When x is 11, which is out here, y is 4. And so I get the same graph, but not shifted left 2. It actually is shifted to the right 2. Because in order to get the same outcome, my input has to be 2 units bigger. Okay? Using the same logic. What does this look like? Well, using the same logic, I should start at a negative 3. Do I? When I plug a negative 3 in, negative 3 plus 3 is 0, and the square root of 0 is equal to 0. So I should plug in what next? I need to plug in something that's 3 less than 1. So how about a negative 2 plus 3 is equal to 1, and the square root of 1 is equal to 1. And we can follow that all the way down. So I simply move left 3. I'll go back to red. I go left 3, and then I plug in all of my points, just like I would before, and it really moved my graph left 3. What did we learn from all that? Numbers that are outside the square root will affect my vertical, will affect my y values, and they do exactly what they say. Things that are inside affects the x. It affects the horizontal, but it really moves it opposite of what it says. This says x plus 3, but it really moves my graph to the left 3. X minus 2 really moved my graph to the right 2. All right. I'll leave the blue. Your turn. Sketch a graph. I'll get rid of this. Sketch a graph of, using what we just said, y equals the square root of x plus 1 minus 4. What does that graph look like? And I'll draw the original one. You can hit pause and sketch a graph of that. All right, I assume you're back. So first thing, what does that do to my green sketch over there, to my original parent function? It moves it left 1. When I say it, I mean this starting point right there. What does this minus 4 do to that 0, 0 starting point? It moves it down 4. So this 0, 0 starting point is now left 1 and down 4. It's sitting right there. The shape of my new graph is exactly the same as the shape of my old graph. So I'll use my fancy technology here. And it's just that exact same graph shifted left 1 and down 4. How do I graph that if I don't have fancy technology? I follow the same pattern as the y equals square root of x. And what's my pattern? 1, 1, 4, 2, 9, 3 from my starting point. Think of 0, 0 as being my starting point, and it follows the exact same pattern. Over 1 for the x, up 1 for the y. Over 4 for the x, up 2 for the y. So I go over 1 for the x, up 1 for the y. Back to the starting point. Over 4 for the x, up 2 for the y. Over 9 for the x, and up 3 for the y. I missed. That was over 10. Over 9 from the starting point. Over 9 and up 3. All right, let's try another one. And while I'm erasing and stuff, you can hit pause and sketch your graph. So let's do square root of x plus, no, we just did plus. Square root of x minus 3 plus 2. Sketch your graph. So there's my parent function. And this will shift my origin left or right 3 and up 2. So I'm going right 3 and up 2. So in blue, here's my new starting point. Up 2 and right 3. From there I shift, or I start by going over 1 and up 1. Over 4 and up 2. Over 9, which goes off my graph, and up 3. And I've got my new graph. Okay? All right, let's do one more. What do you think that does to my graph? That's going to flip my graph upside down. Why? Think about what this does. When x is 0, y is still 0, because a negative 0 doesn't make sense. When x is 1, the square root of 1 is 1, and the negative makes it a negative 1. When x is 4, the square root of 4 is 2, and the negative makes it a negative 2. When x is 9, the square root of 9 is 3, and the negative makes it a negative 3. So I have the same x-coordinate. I still go over 1, but now I'm going down 1. I still go over 4, but now I'm going down 2. I still go over 9, but I go down 3. It's the same looking graph flipped upside down. Okay, what do you think this does to my graph? It takes all the y values and it multiplies them by 2. I'll use the same x values, 1, 4, 9. The square root of 1, or 0, 0, 1, 2, 3, right? But now I take these answers, which are written in my column, and I multiply them by 2. So my new y is going to be 0, 2, 4, 6, because this says take 2 times the square root of x, which is what this is right here. So what does my new graph look like? Let's get rid of some of this other stuff. So here's my original, 0, 0, 1, 1, 4, 2, 9, 3. And my new graph will be over 1 and up 2, over 4 and up 4, over 9 and up 6. It's a square root looking shape, but it's just stretched vertically. All right. That's as far as we're going to go. We can do a lot more. We can flip it horizontally. We can do a whole bunch of stuff, but we'll stick with that for this recording for square roots. All right. Cube roots. Now, I changed my mind. We got to do one more. You have to practice one. I can't just throw that at you and have you not be able to practice one. So let's practice one. So your turn. Y equals a negative 2 square root of x plus 1 minus, no, plus 4. Sketch your graph. I'll get rid of all that stuff. Hit pause, sketch your graph. Okay, I'm going to do this without making a table. Okay, because that's kind of the goal, is I want to see the pattern and use my pattern to sketch my graph. Use something called the graph translation technique, theorem, whatever you want to call that. So what does this do to my original 0, 0 point? Left 1. What does this do? Up 4. So my original 0, 0 is left 1 and up 4. What does this do to my graph? It makes all my y values go negative instead of positive. What does this do to my graph? It doubles all the y values. So let's start working our way across. Notice we have not changed my pattern of x's of 0, 1, 4, 9. I'm not going to mess with that. So I still go over 1 from 0, which is now at this new origin point right there. If you want to do this, put a reference xy axis right there and say, okay, we just shifted the xy axis. Some people like to do that. That would work fine. So now, if I go over 1, my parent function said the square root of 1 is 1. So what does this do to my graph? It multiplies it by a negative 2. Over 1, down 2. Go back to the origin. Count over 4. 1, 2, 3, 4. I'm right here. And down, normally it's 2. Well, now we'll go down 4. So I'm sitting right there. Next thing, count over 9. So I'm over here at 8. Square root of 9 is 3. Multiply that by negative 2, and I get a negative 6. From 4, I go down 6 and end up at a negative 2. And so my curve looks something like this. Let's see if I can get my hand out of the way of my smartboard shadow. Can't do it. Got to come from here. And I get that graph that looks just like that. Shifted, we should know these terms. Left 1, up 4, vertically stretched by a factor of 2, and reflected over the y-axis, or over the x-axis. This is a reflection. Reflection. This is a vertical stretch. And that's a shift right, or translation, left 1, and a translation up 4. All right. Terminology is not super critical, but it's important. It's nice to know. Be able to speak mathematical language. All right, let's try cube roots. We don't know what a cube root looks like, so let's start by making a table. Same question as before. Can I plug in a negative for x? Answer this time, yes. So let's pick perfect cubes, but that are negative. So I know 8 is a perfect cube. I know 1's a perfect cube. 0 is a perfect cube. And 1 is, and 8 is. I could go to 27, but that's way off of my graph, so it wouldn't fit and not mean a whole lot right now. Cube root of negative 8. What times itself 3 times will give me a negative 8? Negative 2 times negative 2 times negative 2. So the cube root of a negative 8 is negative 2. What number times itself 3 times will give me a negative 1? Negative 1. What number times itself 3 times will give me 0? 0. Same answers over here, but positive. So let's sketch a graph. When x is a negative 2, y is a negative 2. When x is a negative 1, y is a negative 1. When x is 0, y is 0. When x is 1, y is 1. When x is 8, y is 2. And it comes from here, passes through these points, and goes like that. And that wasn't, it doesn't have a little bump in there. It's a smooth curve. Okay? There is a graph of a cube root. Now, because we're smart and we can do this, let's use what we just learned about square roots for cube roots. What does that do to my cube root graph? Hit pause and try to sketch it without making the table. You know what it looks like. So what does that negative 2 and the positive 1 do to that graph? Go. All right. When x is 2, or sorry, this x minus 2 makes my graph go right 2. This plus 1 makes my graph go up 1. So when I say it makes my graph, I'm going to use the same logic as before. I'm going to translate one point and use that point as a point of reference. What point would be nice to graph or to move? The origin. And again, I can think of moving the xy axis as another way of saying that. So my xy axis or my origin shifts to the right 2 and up 1. So it's sitting right there. Okay, I put them dotted because they are reference lines. That is not really the xy axis sitting there, and it's not a part of my graph. So I don't put solid lines, I put dotted lines to show these are just reference lines. All right, from there, let's just graph my normal cube root. I go left 1 and down 1. I go left 8 and down 2. I go right 1 and up 1. I go right 8 and up 2. Always going back to this shifted origin, shifted xy axis. And I sketch my graph. Comes from here, try to go smoothly through there, and up. There is my new graph. All right, because I know you're smart, sketch your graph. No, I don't want to do plus 1. You've done the plus 1. Let's go minus 4. Sketch your graph. First thing, minus 4 makes my xy axis shift down 4. There's nothing inside the parentheses causing my graph to go left or right. Simply going down 4. So now, this negative here, remember what it did to the square root function. It took all the y values and made them negative. Well, let's tweak that a little bit, and let's say it took all the y values and changed their sign. In the square root, that was making them negative. That's not true here, because we had some negatives that are now going to become positive. It changes their signs. So I start here at my 0, 0, and I go over 1 and up 1, but now I go over 1 and down 1. I did go over 8 and up 2. Now I'll go over 8 and down 2. I did go left 1 and down. Now I'll go left 1 and up. I did go left 8 and down. Now I'll go left 8 and up. And I have my cube root graph shifted down 4 and upside down, reflected. That is cube roots and square roots. All right. Hope that helps.